Welcome to another edition of the Sim Racing Garage. I'm Barry Rowland, and as you can see, the Accuforce wheel system has finally landed at Sim Racing Garage. It's been a long wait. It's been about 16 months since I signed up on the waiting list, and that's a long time in anybody's book. This is probably the most anticipated and hyped piece of sim racing hardware to come along since I can remember. Can it deliver on the promise of being the best performing direct drive wheel system out there? Well, let's put it through the Sim Racing Garage review process and find out. So let's get to it. Okay, let's take a look at the motor first. You get this unit that comes assembled just as you see it, except the brackets you see on the bottom here, which are the Sim Experience adjustable brackets, do not come in the kit. You have to order those separate, about 40 bucks or so. The motor is very heavy, and we're going to weigh all this stuff and get the details on it as we go along, but this is just what you get in the box part of the video, so we'll go pretty quickly over this stuff. The big hub up front here, it's got a big flange around this side, and there's the hub bolting onto what I would imagine are the 70mm spacing, universal type of spacing holes. So I would probably end up taking that off when I put my wheels on there, put my quick release base on there, and then use my quick release to run my wheels with just running a USB. But if you use his wheel, or if you get the quick release hub that wheels can use this, you can see there's some electrical contacts right there, and they pick up the signals from the wheel. You can see they turn so as your wheel turns, so they don't really move. And what's inside of here is what moves around a ring to pass those electronic signals through. You can also see on the hub it has round or circular indentations on it, and those are the female ends or the receiving ends of the ball bearings that are in the actual hub. You can also see on the front of this is I'm guessing simulated carbon fiber plate, maybe a decal on a piece of aluminum or something, I'm not sure about that. And on the side it has some fins. Not really, I don't know if I'd call them fins more than grooves, because they're not very deep. They're deeper here than they are up on the top part up here. And there's a indentation on the top here. But I'm not sure if this really is a cooling cover or it's just a cover to cover the motor and the electronic and electrical internals to keep them safe. So, but we'll find that out once we get to it and we're actually taking it apart and looking inside and see what makes this thing roll. On the back, you can see there's a lot of places to plug things in. Guess looks like an RJ45, another proprietary plug up here, some USBs over here, and a couple more proprietary plugs over there. And you can see it's got this big cord coming out the back. And it has what reminds me of plugs that you would see on a computer motherboard or electrical supply that go to a computer motherboard. All in all, these plugs are nicely done. They got shrink wrap tubing around them, which makes everything nice and neat. It's got this braided cover. I don't know if you guys have ever run wiring in computers or other electronic stuff, and this is the standard braid that you would get to run all your wires inside of. And this seems pretty stiff, but we'll actually find out and talk more about that when we get into the details of the motor. Right, so I don't know if there's anything else we can talk about the motor. We've been all the way around. Oh yeah, this the Sim Experience little chrome, I imagine this is plastic that they stick on there. It's just a decal type thing. You could probably take a heat gun and take it off if you don't like it. I personally think it's okay, and I'm going to leave it on. I thought it might look a little cheesy when I first got it based on pictures from the internet, but actually I kind of like it. So next we'll look at the controller box that comes with this, as far as what comes in the box. Now we're looking at the controller box, and you can see straight away Accuforce by Sim Experience, and it has a little vent place over here for, looks like a fan, and on one side we've got electrical connections where your mains goes, and some other connections. It looks like what we just saw on the motor where the cables will go into here, but I can't be sure until I'm actually mounting it. On the other side you can see we have a couple of USB connectors, and again what looks like to be a proprietary connector to be used for some accessories. And other than that, until I can actually pull the cover off this and show you more detail, There's not much to see here. So there it is, the controller box. Kind of an ABS plastic cover on it. Not much else to see here. Little serial number on the bottom. You can see that. Alright, so next let's go ahead and take a good look at the wheel, and then we'll look at the cables that come with it, and we can get into the more detailed process of taking a look inside and see how these things work. Alright, so here's the wheel that comes with the Pro kit. Now I was going to get a kit which is the do-it-yourself kit with just the motor and the controller, and it turns out that Bernie was not going to be selling that kit till after he sold all his Pro kits that he was assembling. So I went ahead and went with the Pro kit and got the wheel anyway. And it's a pretty, well, it's just it looks like an eBay wheel that you get off of eBay, and with the red stitching and just your basic run-of-the-mill type basic wheel. I'm sure it gets the job done well. Actually feels kind of nice. Got nice weight on it. And we'll get into details of that wheel, and we'll pull this pod off and take a look at all that stuff and how it's assembled once we get into the details. The back here, like we saw on the motor, you can see the back actually has the ball bearings in it, and here's your plate where you put your fingers and pull back when you're mounting it. It really doesn't pull back very far. You got your shifters over here, which actually are carbon fiber bits, it looks like, and they feel pretty good. Not too long of a throw, but it looks like that throw is going to be adjustable by these two screws on the back. You can see those screws there, and we'll see that once we get there. And on the bottom there's actually a USB controller, and it looks like another RJ, it looks like a phone connector, not like an RJ45, doesn't look big enough for that, and another proprietary connector in the back. The buttons themselves, well, nothing fancy here, nothing to get excited about. It feels like you could feel them pretty good. But again, once we get into the detail, we'll see how these compare to like the kind of buttons that you get on a Sam Maxwell pod, and see what the differences are or how they feel. The stitching looks pretty good on this wheel overall. Just a little gap up here on the red centering stripe there. But overall, not too shabby, and I'm sure it's going to get the job done just fine. But again, we'll get to the details when we get to that. Now let's just take a look at the quick look at the cables that come with this, and then we can get into the details of how all this stuff works. So you do get a few cables with this wheel. Here we have some USB cables, and I'll let you see what the model is on them. Try to keep the video lights from giving you too much glare. Trip lights, which is a good name brand cable, and you get another one there, which is just another USB cable, and these are basically the same cables. You get this, which is a coiled cord with the phone jacks on them, it looks like, but we'll get a detailed look at that once we get them open. But that's what that looks like, just a phone jack to phone jack connection that looks like it might go from the steering wheel to the box. You get, of course, the mains cable, and this is the USA version with the 3 prongs on it and the ground, which includes the ground plug. You see that? And you get this guy. This is a surprise. When I opened the box and saw this in there, I said, wow, look at that. It's the old on and off, inline on and off switch. You can see that there? It will turn your power on and off without you having to unplug it. Now, I remember when I was looking at the box, I said, you know, there's no switch on the box. How are we going to turn this on and off? And, well, that's how we're going to do it. With that. All right. So, that's everything that comes in the box. Now we'll get to each part and have a look at how they work, how they're built, and what we think about the quality of the build. You know, things like the normal things we do here at Sim Racing Garage when we do a review. So we'll get to that part next, and we will start with the wheel. All right, let's take a closer look at the wheel and how this setup works with the pod and the shifters and the quick release. Actually, we'll probably take the quick release off once we get the wheel off and see how all that works. So let's pull the wheel off itself, and you see 6 bolts here. And by the way, this is a universal 70mm pattern here on this wheel. But there's only 3 bolts holding this in. There's one at the 10 o'clock, the 2 o'clock, and the 6 o'clock. These other bolts are just bolts with nuts on the back, and I'll show you what I mean by that. So let's go ahead and just pull the wheel off. And we'll also try to put some other wheels on to see how they fit. So bear with me as we unscrew these bad boys. Alright. I'll just usually just pull the wheel straight up. Now, you have to be careful here, because guess what? See this button? The horn button? It actually is a working horn button, and they've wired it. It's actually wired in over here. Get the spacers back down. So you have to be careful to unplug the wires without putting stress on the circuit board when you take this off. So I'll do that. Just 2 clips, real easy. There you go. Comes off pretty easy there. And we'll just go ahead and get the bolts out. These are about 2.5-inch long bolts, it looks like. So if you ever lose one, it's easy enough to get them again, little cap screws. The wheel itself, again, little button on there for the horn if you want to use it. It looks like it's a functional button, so you can map it to whatever you want to do. And again, you can see the screws here and the nuts on the back with lock washers to cover the holes that aren't being used to actually hold the wheel to the hub itself. And again, generic kind of eBay, you can get these on eBay, Jegs, those kind of guys, JC Whitney, these kind of wheels. They do the job, they get the job done, nothing special. But what we want to do is real quick, oh by the way, after you take that off, there's spacers in there where those screws were. So you got the 10 o'clock, 2 o'clock, and 6 o'clock. So what I usually do is just turn them upside down and try to shake them out. Hopefully they come out for me. And there they are. So now we got the spacers out. We'll put those somewhere. They look like to be about 1.25 inches, maybe 1.5 inches. And just aluminum spacers. And we'll put those next to the screws over there so we don't lose them. Now, if you're going to put another wheel on here and it doesn't have the horn button, then you can just kind of tuck these wires in here against the board. And if you look here, you can see that they have an insulator on the metal part of the clip. So it should not cause any damage or any problems just tucking them in there as you put another wheel on top. So let's see what kind of wheels we can fit on here. I got a couple I'll try. First I'll try one I know is going to fit, and that is the humongous 350mm oval racing type of wheel that Momo makes. It has a really deep dish in it, as you can see. That's like almost 4-inch dish on this. So I know there's no way these pods here are going to interfere with this, and I'll gently lay it here and pull my wires through it. And as you can see, these holes will line right up and you can bolt this right into it. And maybe put a button or something cover on there so you don't have to look at the circuit board and the wires. So that's one that'll fit, no problem. Now let's take a look at another Momo wheel. This is one of my old and goldy. This thing's been through a lot of use and abuse. You can see the suede is worn down. It's all pressed down and shiny. Even though I tried to brush this and keep it nice and wear gloves, eventually this is going to happen to your suede if you use the wheel a lot. And this has been used a lot for a few years actually. This was originally on my ECCI 7000 wheel, and that's why you see all these holes in it. These 2 holes here on the top, and I think these 2 holes over here were actually a different hole pattern. It was a proprietary hole pattern that John made on his ECCI wheels. I had to put a 70mm pattern in there so I could bolt it to a quick release and use it on other wheels, or use the other wheel adapters for like a G27 Thrustmaster and so forth. But let's see if it'll fit. So we'll keep our wires down there, put this on here, and it doesn't look like it's going to work. It's not that the holes won't line up, because they will, but the problem is the back here. This part of the steering wheel is real thick and flattish there. You can see the profile. And once I put it on here, it comes in contact with this back plastic piece that protrudes that's housing all the connectors. So if you look at it sideways, you can see it's kind of sitting lopsided. It needs to be level like that. But now when you put it in there, it kind of sits. So this wheel will not work on here, even if I was adjusted the pods. Well, there's one that won't work. Now I have another generic wheel over here that you can get on eBay and the same kind of places that you can get this kind of wheel. In fact, this one's actually a little lighter than this one is. Maybe it's because it has the ring on the front of it or something. But this is very similar shape to that. So we'll look at this and see how it fits. And unfortunately, it doesn't fit. It won't line up to the holes. But this brings it a nice feature of this particular setup. And that is, you see two, show you right here. These pods themselves are actually movable. They're independent units, and if you look at the back here, you can see the track that a screw follows. See the track back here? So we loosen the screw right there, and we can actually raise and lower them, but we also have to loosen, and the same thing on the other side there. But we also have to loosen these two guys up here, these two screws, so that's their pivot point. And so we'll do that. And by the way, they are 3/32 hex screws, so I'll just loosen that a little bit. And then I can come back on the back and loosen those. The ones in the tracks there. So we'll just loosen that up. Loosen the one over here. And you can see the pods are moving. Awesome. Actually, that's a nice, neat feature they put in here to make those pods adjustable, because now, when I put the wheel on here, some things in there, I can put it in there and the pods will move up far enough to where I can get the wheel mounted and centered on the holes. So then I can tighten my pods back down, try to hold all this together. So I actually have more room than that. You can see how far these things will go. So that's really nice. The wheel didn't fit on the stock configuration with the pods, but the pods will adjust far enough to allow the wheel to fit. Even though I'm getting snug right here, you can see on the edge here of the wheel where it's on the edge of that little pod housing. It's getting pretty snug there. It's almost like a custom fit though when you get it all set up. Pretty cool. So that is a great feature on this pod that they thought about that and implemented it, because they didn't have to. They could have just put the pod the way it was and you were stuck with the wheel that you had, or maybe some other wheels you got lucky enough to fit in here. So hats off to them for going the extra mile there and setting that up. I think that's a great thing. I'm glad they did that. And we just tighten everything back up. And we'll tighten these guys back here back up. So, again, unexpected feature. I wasn't expecting that when I got this wheel, but when I took it apart and looked at it, or took it out of the box and looked at it, and looked all around, I said, well, how you adjust this? How you adjust that? And I noticed the pods looked like they were on swivels, and sure enough, they were. All right, so pods will swivel so we can fit just about any wheel we want to this. And I even fit my favorite wheel, at least my favorite wheel for GT cars, my Momo Mod 30. The ergonomically correct Momo wheel. This thing is just a joy to drive. I really like it. It's got minimal dish. It does have a little bit. But these knobs up here, these ergonomic knobs that you can grab while you're driving, are just really sweet. So this fits in there in a stock configuration with the pods right where they are. You don't even have to move them. That's a good looking wheel there. Okay. So that one fits too. So we've got a lot of wheels that'll fit. So what else we want to talk about here? We're going to, here's what I'm going to do. I'm going to go ahead and pull the hub off of here. Now, before you take the hub off, remember there's contacts in there, electrical contacts that fit the front of this guy down here, so that all this electrical cabling and signaling can go through here, through the center of your wheel, instead of having a USB hanging off of it, like all my wheels do. But to take it off, you can see there's 3 screws that are in that 70mm pattern that were left over because the screw only use 3 screws to attach the wheel to this pod. So I'm going to go ahead and take these off. But we remember there's got to be some wires in this hub connected to the circuit board in this pod. And you have to be mindful of that and very careful when you take this apart. So let's go ahead and do that. Again, bear with me as I get the screws loose. And I've already been in here before. That's why the screws are as loose as they are. I would have them very, very tight once I had everything back together and was going to use it that way. So taking the hub off also allows us to use other wheels directly connected to that hub. Now I'm going to take this off very carefully, and I'll move it over this way so you can see when I pull the hub off. Now let's see if we do it this way, you can see it better. So as I separate the hub, you can see, number one, you can see spacers coming out. Tell you what, here's what I'm going to do. Before they go everywhere, I'm going to do the same thing I did the steering wheel. I'm just going to turn this thing upside down and see if I can get all the screws and spacers and everybody to come out. Like that. There we go. Perfect. Well, sort of perfect. So there's all the screws and spacers and washers, and there's lock nuts on those too, if you can see them here. Get a focus. Alright, so we'll put those with the rest of the screws and bolts. Now we're loose, but you have to be careful. I want to slide everything all around and yank on the cable that's in there. And there is the cable. You can see it there. And down inside I can look and see that they're soldered to this hub. But over here, they're actually, let me turn it this way, maybe you can see it better. There's actually a Molex plug on this circuit board inside the pod. So all I'm going to have to do is very carefully and not yank on these, keep them spaced properly so there's no tension on the wire or cable. And just reach in there, and it's just a little clip that you pinch and it comes off. So now we got the hub loose, and we can see where it was. And there's the little Molex plug. And you can see the circuit board here with the chip. That's the main chip. And these inputs over here are for buttons and for the shifters. Now I would take the cover off the back of here, but there's really nothing to see. It's just some wires over here. So it's really no need to take the cover all the way off. And you can see on the hub side, there's the plug that came out of there. Again, just a little Molex type plug with a little tab on the top of it. You guys can see that. And soldered in the center there with some nice drop of silicone on it. Very nicely done, by the way. I really appreciate quality work, and that's what this looks like. Looks like they did a real good job on this. Alright, so we'll get back to the hub later, talk about that assembly. Now, only thing left to talk about on this is the actual shifters and how to adjust them. First of all, the shifters, they feel pretty good. They're solid. I like the feel. I don't have any problem with how these shifters feel, and the pull is not too far, but you can adjust the pull. As you can see, I've got this one kind of adjusted way out compared to this one, which is kind of close in. And it's a very simple matter of adjusting it. You have 2 screws on the back here. Alright, you got this screw and you got that screw. The screw in the front is actually pushing down, let me get some light on it, on the little switch in here. So you got a switch right there. Well, that's the arm to the switch. I don't know if you can hear that, but that switch is your shifter switch. So this screw here and back here will push down on that. So however you adjust this paddle shifter, and that's done with the back screw here, you have to adjust the front one to make sure that you have enough reach on this screw to keep pushing down on that and make it click. So you shift. So what I'm going to do here is take the back one. Right now it's all the way down, or out rather, which lets it go all the way towards the back of the hub. The reach or the amount of travel really doesn't change that much. But where it's positioned, if you've got a big hand, you'd have it way out like that. I have a little hand, so I would want it further in. So where you have it positioned is really what these screws are actually changing. So I'll undo that. But what I'm going to do is undo the top one first where the switch is. And it's got a little spring on the back of these screws. And as I take it out, you can see it's coming off of that switch clicker. And now I have room between them to let this paddle come forward. And how I'll do that is take the back screw and I'll be screwing that in. And as I screw it in, the shifter's going to move because it's jacking the whole shifter paddle that way. So I can just keep screwing it in until I make contact with the switch again if I want, as you can see. But you don't want it to go too far down on the switch because then it'll stay clicked all the time. I'm going to go ahead and put this up pretty high, and I'll back the screw out a little bit some more so I have more room. And you can go as far on this back screw, as you can see here, as the spring will allow. That's about the limit right there, because the spring's fully compressed and it won't compress anymore, and that's as far as it'll go, which is a good thing because you don't want it to go too far and then jack this front screw into the switch so it doesn't work anymore. So now that I have it there, I will adjust the front screw again against my little switch arm to make sure. And you can adjust the throw on how easy it is to click it too, or how far you go. So now I have it screwed in pretty good there against that clicker. And you can see the travel is still there. It really doesn't change the amount of travel, but the position has really changed. It's really close now. I don't know if I'm really going to run it that close, but I just wanted to show you guys the range of the paddle adjustments here. Very cool. Now you don't have an adjustment as far as out this way. Well, you do, but no, I guess you don't. If you look at the back here, now that I look at it, these screws are holding it on, which allows you to flip it around. If you don't like these pointed up, you can point them down if you want. And these two holes here, you can't really move this paddle in because the screw's stopping it. So you can't move it out because it's already as far out as it's going to go. But this is a pretty comfortable position. I've already had the wheel in my hands with the shifter where I wanted it, and I didn't have any real problem with it. Again, a very nice adjustability range in this for all size hands. I don't imagine anybody could have a big enough hand where they couldn't find a good solid position for where there's reach around the wheel and grab this shifter. Very cool. I actually like the way that adjusts. It's very simple, it's very quick, and very easy. All right, the buttons themselves, we haven't really talked about those. Well, they're just buttons. I mean, they get the job done. I call them marble buttons because they kind of like have marbles. Not a real definitive click to it unless you're really paying attention. You got gloves on, you'd never feel it, but you really don't have to worry about something like that so much. I don't. I mean, as long as it works, it works. Sure, it'd be nice to have a nice positive tactile click on it, but as long as it gets the job done. All right, is anything else we want to talk about the hub itself? Or rather, not the hub, but the pod. Nope, I don't guess so. We talked about all the wheels, how to fit them. The adjustments on the pods on the top will come up. And we talked about the adjustments on the shifters, and we got a little peek inside of what's going on here. Now what I'm going to do is, the next segment we'll go to the hub itself and talk a little bit about how it works and how it connects over here to our motor. So when we come back, we'll be looking at that. Now we're going to take a look at the quick release hub system on the SimExperience wheel. This is a very stout system. When it's on here very, very tight. And you push this little wing handle, I call it like a wing because there's two of them, as you can see here. And we press that back towards the wheel and away from the motor, and it comes right off. Very easy. Now you can see here on the male piece of this hub, there's indentations machined into the side of it. You've got 6 on one side, and you got another 4 over here. And of course, there are corresponding bearings or ball bearings in this hub. There's 4 on that side, and then on the other side, you can see there's 6. Now they're all poking out on this side of the hub piece, the female piece. And the reason they're doing that, there's a ring in here or a collar all the way around here. So it's a round collar that's sitting on top of a spring underneath it that goes all the way around. And that keeps pressure against the collar, which keeps the bearings out. So you can see how flush they look inside. That allows us to insert this female on top of the male and push it in. Now once we push it in, the action of pressing it on pushes this collar or ring back against the spring far enough to let the ball bearings fall down. And when they fall down, they fall into their corresponding indentations on the male piece of the hub right here. And if you line these 4 bearings up with the 4 pieces or the 4 holes that they have here and just push it on, it'll work that way. You don't have to use the wing mechanism or the handle springy. It just claps on. Very nice. Very tight. I like that. Very, very tight and nice. And of course, to take it back off, what we're doing is we're pushing the ring back. And when we push the ring back, it takes pressure off the bearings. And I'm going to try to show you here if you can see this. The bearings are over here under this black piece right now. And as I pull this off, what's going to happen is when I push the wing back, it pushes the collar back and takes the pressure off the ball bearings. And you can almost see that. There's the ball bearings there. You see those. They're actually still sitting down in their respective slots. But as I pull it out, you can see that they're coming out of their slots and riding on top of that hub piece, the male hub piece now, which is actually causes them to push out. And when they push out, that allows that collar or ring to snap back into position, and it keeps them out. So I can actually demonstrate that. And you notice, by the way, while I'm doing all this, our little cord, I curled it around in there so this cable will not get any wear and tear on it while I'm doing all these demonstrations on the video. So I'm going to demonstrate this ring as, actually not demonstrate the ring going in as the male pushes against it and the bearings get to fall down and keep the ring back. So I can do that by taking a couple of my little soft plastic thingies here I use for a lot of stuff. I love these things. Actually, you can see these things. They're like little glass tools that a lot of glass guys use. I used to do windshields and glass a long time ago, and I discovered these then, and I always get them because they're just so handy for everything. Anyway, so we'll go back and press down on the ring, and when I press down on the ring, you're going to watch this collar's going to snap up, and the bearings will be pressed in then. And the bearings being pressed in allows it to snap up. So let's go ahead and do that. And I'll just push down on both sides at the same time so it's even. You see what happened? It snapped up. So now that's what happens when you push it on the male piece of the quick release. And you can see now that's the position the ball bearings are in when they're attached, or when this part is attached to the other part of the quick release. And you can see the collar now is pushed up against those ball bearings, holding them in place so they can't move. All right. So to reset this so I can use it again, I'm going to have to take it and put it on the hub again, make sure I got the 4 lined up with the 4, and push my wing lever back as I'm pushing it on. And get them lined up, and it pops back in. So now when I take it off, you can see the collar is back where it's supposed to be, holding the bearings out. Pretty nifty setup the way these quick releases work. I really like this. It's very tight. It doesn't move anywhere. Now, as far as the longevity of this kind of quick release, I don't know. I know a long time ago when I was using quick releases, I used the ones that have the grooves, multiple grooves or splines. And it goes onto the splines and it locks with a lock ring, and I've used these before too. Anything will wear though over the period of use, and I imagine eventually this will wear a little bit too because it is aluminum, or maybe it's steel. But regardless, it's going to wear, and it might get a little bit of play in it, but probably not enough to make a difference. Anyway, so what we're going to do next is we're going to go in and take this hub off and look and see how this electrical pass-through system works. It's very ingenious, actually. I really like what they've done here and how they're doing it, and I think you guys are going to like seeing that. They did a good job setting this up and making it so it works, and we'll talk about that when we come back on the next segment. We're going to take this hub off now, the male piece. Because remember, we've gone over this piece pretty much and how it all works, but now we're going to talk about these electrical connectors and how this thing works. How in the heck can you turn this wheel and not get the wires all tangled up in there that are sending all the signals from our buttons on our pod and our shifter? So it has to be something in there that's keeping it from tangling up. And the design is very curious the way they've done that. Now, just as a quick review, you can see that there's pins on the inside of the female hub, and they're actually spring-loaded pins. I can actually take a little anti-static thing. I always use anti-static pieces. And I can actually push down on that pin a little bit, slid off. But you can hear it. So those pins are actually spring-loaded, so that they go in here and they make contact against these pads here and press in so they keep a good tension on those pads and don't slip off. So what I'm going to do here real quick is pull the male part of that quick release hub off. Now I know I've got some wires in here, some kind of electrical connection, so I'm going to be very, very careful about how I do this. And I'm going to be very meticulous. And I don't recommend you guys do this unless there's something wrong with your wheel and you need to fix it. I've been working on mechanical machinery for a long, long time, and I have a pretty good process down now on how to take these things apart, fix them and put them back together. And also, I have a magnetic tray to keep my screws from flying around. So go ahead and bear with me here while I get these loose. And I'm keeping the top one centered there for a reason. It'll be the last one I take off. And that'll allow me to get the rest of them off without it falling off. And remember, I know there's a wire in here somewhere, and I don't want them falling off and stretching or putting any stress or undue stress on the wire or the connections, soldery connections, any of that stuff that's in here. Now I can get the last one. And that's going to be this one. Now I'm going to support it, though, when I take the last one out. And by supporting it, I can make sure that nothing gets stressed inside. So I got that one out. Now, get you a close look here. And I'll try to get in a little tighter. So let's see what's in here. I'm going to pull this off, I'm going to look, and I can see there's wires. Hope you guys can see this too. There's the wires. Now I can also look inside here and see that there's soldered to this piece. So there's no plug to unplug. There's no way for me to attach these wires and get this loose. So now I have to look on the other side and see what's going on there. So you can see that there's a Molex plug in there. But you know what? That thing's in there pretty good. I'm not sure if I even want to unplug it there because it's going to be very hard to get it back in. Not only that, but if you can see, look at those circular traces on the circuit board in there. That's a concern also. If I'm in there trying to plug that Molex plug back in, remember, just because we take something apart doesn't mean we're not thinking about how we're going to come back out and put it back together, and the easiest way to do that without hurting anything. So I'm going to leave that plug in there because I don't want to go in there with a pair of tweezers or something trying to get that Molex back in and possibly touch any of those circular traces on there. And it also gives us, by the way, a clue of how this is working. Circular traces. So they got circles in there, which are traces on the circuit board. So what I'm going to have to do, and by the way, that shiny metal piece there is actual shaft of the motor. So what we're going to have to do here is put this back on, just like I took it off, and then I'm going to have to just take the whole thing off right here. And that's a 5mm bolt right there holding everything onto the shaft. So what I'm going to do is put the hub back on just like I took it off, very carefully, not to stress any of the wires or the wiring in here. And when we come back, it'll be back on, and then we'll just pull the whole assembly off and see how that works, and maybe there's a better way to unplug everything. So when I come back, that's what we'll do. So we're back, and we're looking at what we're going to do to pull this hub off. Well, if you look all the way around the perimeter here, there's only one bolt. And I already know that's a 5mm. So that is holding this assembly to the shaft of the motor. So the only one way to find out what's going on is to take it off. So that's what we'll do. Once I break it loose, I usually try to just use a regular driver And we'll pull it out. While I'm pulling it out, I'll see if I can't get it. It looks like it's coming loose already. How far out this bolt has to come. Yep, there it is. So I'm going to leave it in there because I don't usually like taking things any further than I have to. So now we're going to pull this out. Again, very carefully because we know there's wires in here and I have to see what's going on before I decide what I'm going to do. And as I'm pulling it out, I'm starting to look and see what's going on in here. I don't know if you guys can see that, but I see a white, looks like wire on the top and the bottom down here behind this hub. So I'm paying attention to all this stuff as I'm taking it off. And I can also see some wires back in there. I don't know if you can see them, but there's some wires behind here on the other side where my back of my hand is. So I'm going to slowly pull this out and make sure I'm not putting any tension on that wire. I'm paying attention to this wire back here, and I can already see there's a Molex plug right there. So there it is. So what I want to do is get that off as soon as possible so I don't have to put any stress on it. So I'm just going to leave this hanging here for now, and I'm going to go get some tweezers or my special pliers that I use. These are smooth pliers that won't mar anything. And I'm going to go in there and take that Molex plug loose, and these will work perfectly for that. Just get it in there, squeeze a little bit, and it comes right out. Easy as she goes. And there's no more connections or wires, so now I can just slide this hub straight off. And there it is. So I'm also paying attention to what was going on with these two things as I took this off. And I'm looking in here inside my hub, and I see that these are like pins. They're pretty stiff pins, these two white things with rubber coating on it, or tubing. And I'm trying to think what they're for, so I'm looking at the circuit board as I took it off, trying to figure it out. And I think I have. I can see that there's only two things that look the same here, and that's this here, this hole right there, and the hole down there in the bottom. So I'm thinking to myself, these must be some kind of guides or locating pins, if you will, for the back of this hub. So I'm going to remember that, because going back on, I'm going to need to know this stuff. So we've got the hub off in one piece now, and that's great. And you can see the circuit board on there. And get a little focus. You see it's some experienced circuit board. And 2014 is the patent on it. Version 102, the way I'm reading it. You guys can read that. Now, again, I'm curious, how's this thing working? I know the Molex plug's in there, but how's this thing work? And what was that? Look at that. This thing actually rotates. Well, what that really means is it stays still, and the hub rotates around it. Aha. So what's going on here, and I can push in on this a little bit. I can see there's some spring tension on this. This whole circuit board here has some tension on it from spring. Now, I'm not so curious that I want to start pulling this off and then have springs flying everywhere and never be able to get this thing back together the way it's supposed to be put together. I'm sure I would eventually, but I really just don't want to do that if I don't have to. But I think I've figured out how this works now, because remember when we pulled the front off, we saw circular traces on the circuit board on that side. So that circuit board is still in here behind this one. So there's actually two circuit boards. You got this one and you got one behind it. And those circular traces are allowing this wheel to turn, and there must be some pins in here that are riding on those circular traces that are wired to this plug, so that as the wheel turns, it stays still, because remember, these locator pins over here are keeping this from turning. But the circuit board behind it is turning, and you can see that. If you watch it, there you go, you can see some of it right there. See? So you can see the circuit board behind it. And if I look at it long enough and spin it all around, I can see different places being shown to me by the holes. And I can actually see what's going on in there a little bit. So that's how it works. Got two circuit boards, spring tension that's holding the pins against those circular traces. So as you turn it, those traces stay in contact, similar to the kind of pins that we saw in here, I would imagine, spring-loaded, so that they stay on there. Let's get you a better focus there. Pretty cool, huh? That's pretty ingenious, actually. I like the way that works. So it's very cool. I really like that. So that's the mystery of how these electrical connections are getting through here. Very ingenious. Like I said, they've done a really good job on this. I'm impressed. It's not something simple to do this. It takes a lot of R&D and a lot of time, a lot of trial and error, if you will, to get these things right. And this looks pretty right to me. All right, so now we know how the electrical pass-through is working between the hub and this hub, and our little Molex plug hanging off of here. Now also I know that if you'll notice on the shaft of the motor here, there's an indentation in there, or a hole drilled actually, to where the bolt in here goes down inside of there as you tighten it down and locks it down. So when I put this back together, again, I'll be very careful. I'll know where this is, but I'm going to have to make sure I line this up, the back circuit board up, with my locator pins on the top and the bottom to get it in the right orientation as it goes back on. Make sure that those two slots that I was looking at before on the top and the bottom, there's the top, are located in the same place with those holes, and as it goes back on, then I can get my Molex plug plugged back in just by squeezing it back in there. And just push it all back on there like that, and as long as everything's lined up like it's supposed to, it goes back on like it's supposed to. Very nice. But I'm not putting it back on now, because now that I have this off and I see this motor shaft sitting here, I'm very curious about what's inside here. And I think I'm going to have to pull this cover off the motor just so we can take a look inside and see how this thing is configured and see the motor inside. I've seen pictures on the web of the motor inside of here, but I would like to see it in person. And as you can see on the back here, we've got some things we're going to have to undo. Lots of bolts there, screws. But we'll just take our time, do it slowly and methodically, and it shouldn't be that big of a deal. And by the way, we're going to take this plate off, and I can see right now, remember I was saying that this could be a metal plate with decals on it or something like that? Well, I can actually see now, just by seeing the ridge here, this is actually a carbon fiber plate. A real carbon fiber plate on your wheel. Get a little closer here for you. All right, so that's what we're going to do. We're going to go ahead and pull this housing off. There's a lot of things I'm curious about, as you know. I want to see if this is a heat sink, this cover is, or it's just a beauty cover, or what's its function. It doesn't have a lot of grooves or ridges on it like most heat sinks you'll see on heavy transistors inside of power supplies and things like that. It's just got a few down here, and these are kind of, well, not very deep at all like we saw before. So I'm very curious of what's inside of here and what this cover is doing actually. So when we come back, what we're going to do is we're going to take the cover off and see what's underneath it. I'm not going to make you guys suffer through me taking all these bolts apart and seeing how this thing comes apart, because you really don't need to see that anyway. So I'm going to go ahead and take this apart and see what's inside. So when we come back, we'll be looking at, hopefully, the shroud off and the motor itself. So now we're back, and here it is. This is the motor. This is the power plant for the SimExperience Accuforce wheel. And I have to tell you, it's a very heavy little piece of kit here. This thing is heavy. It's very stout. And we're going to find out how heavy. I'm going to take a couple of measurements here. So let's get my scale over here. Turn it on. I'm going to put this on, if it's not already there, on pounds and ounces. And it is already there. Okay. So, I guess you guys see that pretty clear right there. Let's see how much this motor actually weighs. I'm guessing 10 pounds. How close am I? 11 pounds and 10 ounces. That's heavy. And it's not a very big motor, so that means it's also very dense. So now that we got that done, we know how much it weighs. we'll get some more measurements on it here. Now I have it being the case itself about 6 inches without the back stub there. Now if I take into account the shaft and that, it's just over 9 inches. 9¼ inches about. And it should be square around, so that's what it looks like anyway. It looks like 3½ inches. And I'll check it this way. And again, yeah, more like 3¼ inches. 3 5/8 maybe. So yeah, 3 5/8 around this way. Now the shaft itself, let's see if we can figure out what that is. And it looks like it's miking out to about 5.5, so a 1/2 inch for the shaft. And if you look closely at this motor, you can see that it is a series of iron plates. So the stator for this motor is internal, of course, turning within these iron plates. That's what makes it so heavy. These iron plates, it's like a transformer. If you see some of these tube amplifiers and audiophile equipment, same kind of thing. This thing's got a ton of these plates in them, and they're very heavy. And let's take a look at the actual markings on it. You can see it's actually their proprietary motor, Sim Experience. Sim X34 4000 revision 1. And that's 1.8 degrees. I'm imagining that's something to do with the phase of the electric motor. I'm no electrical engineer, so I don't know. Maybe someone can chime in and make a comment about that. 9.5 amps. I'm not sure if that's peak or just average. And in the back you can see that there's a little circuit board there with a Molex connector. Controller. Signals are sent that way, and these are the, I imagine, the power. And this is again is like a motherboard Molex 4-pin connector. Got 4 fairly good sized gauged wires coming out of it, the motor itself. And I have to say, I was most pleased on how this motor comes out. The motor itself is attached as a unit or an assembly to that front plate we saw when we took the hub off. And this metal plate, remember the locating pins? There they are. This is actually laying on top of this. And this is a steel plate, which got a very nice powder coat job done to it. And it's very good finish on it too. This is either this was CNC'd or water jet cut, probably CNC'd, what I'm thinking. And it's very nice powder coat job on it. Again, I like quality stuff, and that's what this is, no doubt. This plate fits in the middle there. And of course the shaft of the motor goes through the hole in the middle. And you've got 4 of these bolts. These are 5mm bolts that are going through the motor like this. And we'll go through the 4 holes here. So this is all one assembly when you bolt it together. And when you take the front plate off, there's actually these torque screws, and these are T25s. And they're going across the 2 holes here and the 4 holes across the bottom. So what I'm getting at here is this is really an easy thing to do as far as taking the motor out of the housing here. And the housing, by the way, it turns out it's not a heat sink because it's not attached directly to the motor. The motor actually sits in the bottom here and is just secured by this plate when it gets screwed into all the holes around here. And you can look in the housing here. Get a little closer look at that. It reminds me of the metal housings that you see in some electronic components. And you can see there's a circuit board in the back there. If I can get the light on it. And that circuit board would be easy enough to get access to on the back with the same type of situation on the screws and bolts. So that I would not have any hesitation to be able to take that plate off and work on it if I needed to. We have a plug here that plugs to the back of the motor for power. And then we have the Molex connector right here. It plugs into the back of the motor on that Molex connector. And then this other one you see, of course, is for the hub that we took off before. Very simple, actually, which, again, you know, hats off to Bernie and company for not making it a complicated assembly, which is going to be very difficult to work on. If one of these motors ever goes bad, which I'm not saying it will, but if it ever did and it needs some kind, and you need to replace it, it's a very simple matter to get this thing replaced. Anybody with some basic mechanical skills and seeing it done before, like in this video, should have no trouble in replacing the motor and be back driving in no time. So again, I really appreciate the fact that it's going to be an easy maintenance item, because coming from a mechanical background and working on cars and regular cars, race cars and everything, it's always nice to be able to get to something that's made to be worked on instead of something that they put it all together at the factory and they stick it in a housing and there's no way to get to anything without screwing up your hands and having special expensive tools to reach things. I am impressed so far with what I'm looking at. And by the way, that plate we were talking about a while back, that really is carbon fiber, because I can see it now. The whole thing is out. Right, so what we'll do is we'll get everything put back together. Shouldn't take very long. In fact, it only takes me about 10 minutes to get this thing assembled. And we'll get it all normaled back up. We'll get the mounts, these brackets, and we'll talk a little bit about these brackets when we get to the mounting part of mounting it to the SimExperience 8020 rig that I have set up on it. And once we do that, we'll get back and talk about how I'm going to mount it, when I'm going to mount it, and then we'll start driving it. So when we come back, it'll all be put back together with the brackets back on it, and then we'll discuss some of the mounting options for it. So here's the brackets we're going to be using. These are the official Accuforce motor mounting brackets from SimExperience. There's another guy or company that makes these out there that are compatible, some very similar to this, that's also compatible with the housing mounts on the bottom or the holes on the bottom. I bought this one because I figure a lot of guys will be buying these because they are coming from SimExperience, and when they buy their wheel, they'll probably buy one of these. Really not a lot to them. They are aluminum as far as the metal pieces go here, the big metal pieces. Of course, everything else is steel. They are sporting some steel threaded inserts, so instead of tapping holes with threads, we put some inserts in, which is actually a little bit stronger with such a thin piece of metal here. If it was a thick piece of metal, then you probably wouldn't need the inserts. But it's good they put them in there just to make sure that they're going to be nice and durable and strong enough to hold the wheel. Now on this side, of course, let me just show you a quick adjustment. It's pretty self-explanatory, the adjustments on this. This is the bottom side. This will be mounted to a plate, a table, or whatever. And this is what will mount to the wheel. So when you turn it the other way, you'll be loosening this guy so that you can take this one out and adjust whichever hole angle that you need for your situation. Very simple, but effective. And it comes with, of course, 2 bolts already in it because of the angle adjustment bolts. And it comes with some of these. And these are some 5mm bolts and washers that you use for these holes to attach it to the housing. Now, as far as attaching it to something else, you're on your own. You got to get your own bolts. But I have like most of you guys probably have a big box or something full of the extra screws and bolts and nuts over the years you have acquired. And I had to too. And I found 4 of these. So they're 5mm, and they'll fit also in to these. Now, if you look at the bottom of this housing, let's see if we can give you a shot here. Angle the light so you can see it. There's 4 holes on the top and bottom, and the holes on the bottom of the brackets here actually correspond to these holes. So I could actually mount this if I wanted to. Let's see if we can get the right one for the top. And you can know there's 3 holes there. We'll actually line up with these 3 holes. Perfectly, actually. But I'm only going to use 2 bolts, one in the back and one in the front here. I really don't think I'm going to need the 3rd hole there, because once you get these tightened down, I think it'll be just fine. You won't have any issues as far as, even though this motor can put out some torque, I think that'll be just fine, especially when you're using big bolts like this. So, anything else we want to talk about the bottom here? It's pretty simple as far as this stuff goes. Not a whole lot to point out. I will be mounting it. I can't point out this. I'll be mounting this part of the bracket to this bad boy. This is my steering wheel mounting plate that has seen a lot of use over the years, and it's a 7000 series piece of quarter plate aluminum. Got this off eBay from somebody. I can't remember who, because it's been a long time ago. And as you can see, it's got a lot of holes in it because it seems like every single wheel I get, I have to drill new holes because the patterns are different. But that's why I got this plate, so I can keep drilling holes as long as I want, and it's still going to be a nice stiff piece of 7000 series aluminum. It's not going to bend, it's not going to give. Now, I have two big holes on each side of this plate, and what they're used for is mounting to my, you guys may have seen in some of the videos, my 80/20 steering wheel mount that I use on my SimExperience rig. Now, it takes these little longish bolts that slide into the channels of the 80/20, and this little screw or bolt here screws into this, which is actually tapped with threads. So I'll just mount one of these through here like this, mount one of these on the other side like that, and that gives me 4 of them, 2 on each side, and that also allows me to slide the plate back and forth when I loosen them. So it gives me an in and out adjustment just by loosening these screws here. Now I've already drilled out the plates for where I'm going to be mounting this wheel, and I'll be mounting them here. You can see the 2 machined inserts. I actually have a hole. Where did I put those holes? I believe they're over here. I think I got upside down. There we go. So I've got 2 holes drilled here. Where is it? Here and here. I believe that's where they are. Let's see what matches up. Yeah, okay, it's those 2. So it'll be, anyway, it's going to be those 2 holes, and I got 2 holes over here also that's going to correspond with that. So all this will match up. Once I get the motor mounted to the brackets themselves, then I'll mount the whole package on top of this plate. And then I'll be ready to install it in the rig, and I'll show you guys that once I get it installed. So I'm going to go ahead now and get everything assembled so I can install it in the rig, and once I get it sitting over there, we'll take a closer look at how that went. Alright, a quick look on what we just did. And you can see I have my 7000 series plate mounted with my 4 bolts that I cut the holes for, or drilled the holes for. I also have my little nuts and screws mounted so that I can slide this onto my 80/20. And you'll notice this is a pretty good angle on this wheel right now. Let's set this down. I'm probably not going to use this angle. Probably going to drop it down. I'm thinking maybe even the lowest position because I like my wheel pretty much straight. But that's all personal preference. Some people like it high, and of course it all depends on how you mount to your sim also, or how you're mounting it. You might need it to be at this angle to be able to get comfortable with it. So at least we have choices, and choices are good. So I'm going to go ahead and get it over to the rig now and slide it in and see how it's going to fit. Alright, we're back with the motor and wheel mounted. As you can see, it's mounted to that 1/4 inch aluminum plate that I use, and that in turn is mounted to my 80/20 profile that I have used for all my platforms for my steering systems because I like my wheel a little higher. And this profile here, the way I have it mounted to the cross member on the front of this rig, is much stiffer and more stout than the 1 inch by 1 inch square bar steering wheel mount system that came stock with this system. I really never really liked that because it had too much flex for me in it, and I talked to SimExperience about it, and they didn't feel like there was too much flex in it. And there's going to be flex in everything, no matter what you do, especially when you're running these heavy duty direct drive wheels or any heavy unit that you're going to use, like a ECCI 7000. That's pretty heavy too. And there is going to be some flex. You can see the flex here. If I push up on it, it will flex a little bit, and I'm pushing up pretty hard, but it won't flex any further past that point. And I also, you can push down on it and it'll do the same thing either way. But it's very tight and it's really not moving, but there is some flex in it. And I can't tell if the flex is actually in the 80/20 or it's actually in the cross member that the 80/20 is mounted to. So it's got some flex in it, no doubt. And actually the wheel has some flex in it too. I'm not sure if you guys are going to see it. I'll look on the video when I'm editing, but I don't know if you guys can see this, but there's some flex in this wheel. Wow, that's unexpected. I didn't think I know this is an aftermarket entry level, we'll call it, steering wheel that's $30 to $40 at Jegs or J.C. Whitney or any of those shops that you buy these kind of things, eBay. But I didn't think it would flex like that. Or maybe it's just because I don't know if there's any flex on the hub up here. I can't really see it. I'm gonna have to look at it when I see the video. But yeah, this I'm not sure about this. This ain't really flexy. Wow. Okay. Well, you know what I'm gonna do? I was just gonna go onto the driver setup and everything, but because I found this, I think what I'm gonna do is take this pod and wheel off of the quick release and mount one of my Momo wheels with the Sam Maxwell pod, electronic pod, and mount that to the quick release and see if we have the same kind of movement in it. I don't think we will because it's a Momo and I think they're stiffer than this, but this is, like I said, I wasn't expecting this, but and it's flexing a little bit on the platform too. I don't want to take away and say it's all in the wheel. There is some flex there too, but boy, if you can see what I think you can see when I'm doing this. This is, and I'm not really pulling that hard on it. Not that big of a guy. Okay, so let's go put the Momo wheel on here and do the same thing and see what happens. And we're back with the Momo Mod 30 with the Sam Maxwell pod mounted. I know I'm probably being a little biased, but I like this better already. This is just a great feeling wheel. If you guys ever get a chance to get your hands on a Mod 30, it kind of looks funky when you first see one, but it sure does feel good when you're driving it. Anyway, we can see now that we still have some flex going on here, and I'm doing the same thing, but now it looks like it's not so much the wheel doing the flexing. There is a little bit in it, I can feel that. But, it seems like there's something else going on here. The pod, I know the Sam Maxwell pod is very stiff because of the stuff that he builds that out of. And we've also got, if you'll notice, all 6 screws in here into the back of this quick disconnect hub. So I was able to get all 6 of them in there instead of, remember the other wheel has only 3 mounted in there because they have to mount the pod separately from the wheel to the quick release, like we saw earlier in the videos. So now it doesn't seem like it's the wheel itself doing the flexing. It feels like there's something else in here. But just to let you know that, it's probably, when you're driving, I don't know how much you're going to be able to tell that with the other wheel in pod, but I can tell right away that it's not the same. Not only that, but this is a lighter setup too. So, yeah. And you can still see the flexing of the 80/20. But I watched the first part of this video when we were talking about the other wheel, the Accuforce wheel, and I noticed that this button box is moving at the same time everything else is moving. So yeah, the flex is over here in this 2" by 2" steel tubing that the front of the frame is made of, where I'm actually mounting this to. So that's where the flex is coming from, because I can see everything else over here moving along with it. So, but yeah, it's there's something going on here, but I don't really know if it's going to matter when you're running it. But when I do these videos, as you guys know, I like to check everything and see what's going on, so you can make your own conclusions from what we've seen here. But yeah, there's still something. You can almost hear it. And everything is tight because I double checked it before I put the Momo on. I checked everything. Everything is nice and tight. So anyway, I'm not sure if you guys would notice that or not when you're driving rather. Probably not. But boy, this Momo sure feels good on here. Of course, it feels good on the Bodner and the other wheels too that I've used. All right, so next we'll cut to the firmware upgrade, or firmware upgrade process, if you will, for this steering motor and how that goes. And then we'll actually getting into like iRacing and driving the wheel as a standalone wheel and as a Sim Commander 4 controlled wheel, and see what the differences are between those two. So when we come back, we'll have the other wheel mounted back on here and checking out the firmware update. So here we are at the firmware update routine. First of all, the Sim Commander 4 hardware detects the wheel, then says you need an update to your firmware, and you say yes, update me, and then this happens. So we get our bouncing balls going from left to right, and left to right, and it'll continue bouncing like that for a while. At least in my case it did before I decided it wasn't going to update. So a quick trip over to the Sim Commander Accuforce forum, and I found the solution was to power cycle the wheel and try the firmware upgrade again. Although you must be careful here because you could fall into a trance watching these dots bouncing around. So anyway, once the firmware is updated properly, this is what you see. Now it's all green, and our firmware was successfully updated, but for some reason I kind of missed the bouncing dots. Alright, so the next we're going to see how the wheel does boot up, what routine it physically goes through when we boot it up, and if everything looks good there. So when we come back, we'll look at that. Alright, so you can see we have the wheel ready for boot up. So we're going to press the power button, and it's going to go through its boot up sequence. And it's going to first turn to the left, then it'll turn to the right, then it'll turn back to the left. And we can see here it's not centered. So we just go into the Sim Commander 4 software, we'll center the wheel, and then hit save in the calibration part of that software. You can see it's centered now, and we hit save. Now we're going to reboot the wheel and watch it spin around, and it should end up on the center if all went well. So there it goes, back to the right, back to the left, and there it is on center. Outstanding. Alright, so now that we have the wheel calibrated and centered in the software, now we can actually go into the software itself, and I'll show you a quick shot of what that looks like. Sim Experience Control Center. This is where you'll be making all the changes to your wheel. This is the actual settings tab, and you go down to Sim Device Manager, you do the drop down, you'll see all your output devices, and you can see, because I have a full motion simulator with a GS4 seat and Sim Vibe, there's a lot of stuff in there. And we're interested, of course, in the Accuforce steering system. And when you click on that, this comes up, select a device, you'll see save settings to controller over here. Set wheel center, which you saw the results of that once we centered our wheel before in the video. Reset and calibrate. And we have a mode which goes from soft, recruit, high peaks allowed, then default. I always select the highest thing I can just for the heck of it. And you can see my firmware version over here is 1.14 now that we have it upgraded. And down here is sliders that control the basic settings. I would kind of compare this to the basic drivers that you get with another wheel like a Fanatic or a Thrustmaster or a Bodner or what have you. That you do your basic settings here. You have sliders that adjust things. Here's an intensity slider at the top. So you just slide it back and forth, change the percentage of intensity. We'll leave that at 100, of course. Smoothing, I'm just going to leave everything like it is and worry about making adjustments later once I'm actually using the wheel. There's a peculiar thing down here. It says halt force feedback or halt feedback when Sim Experience wheel button is removed. And you can check that, but I'm not sure why you would want to check that, because once the wheel button box is removed, that would be someone using their own wheel. Not sure why that's even a feature in there. I'll try to ask some experienced guys and see if I can get a response back from them on that. Anyway, I'm going to leave it unchecked because I'll be running other wheels besides the Sim Experience wheel and pod system that comes with it. Right, so doesn't seem to be much else to look at here. So what we'll do now is we'll actually start up iRacing and see what the options are as far as tuning the wheel when we do that. So when we come back, we'll have a look. Alright, we're in the output mixer, and that is over here in the Manage Sim Setup buttons. And output mixer, I'm going to fold this back up real quick just to give you a quick look. Also controls the seat, which is the two actuators on the back of your motion seat. Traction loss, which is the single actuator that controls the traction loss on the back of the rig. You have G-seat back and bottom adjustments, and you can adjust them independently of each other, the paddles or the panels that move. SimVibe chassis, and I have an extension to the SimVibe for my seat because I have a transducer on that. But what we're concerned here with mostly, of course, is the Accuforce steering wheel. And you can see the smoothing is set on 1, intensity is 100%, and same if you hit the drop down for all the settings available, then you can see 100%, and on intensity, or rather on intensity up there for feedback, and smoothing is at 1, just like that. So those are the basic smoothing intensity sliders there. When you drop it down, then you start getting a little bit more particular, and you can select different things: inertia, friction, dampening, smoothing, again, all kinds of stuff. This is where the waters run pretty deep in Sim Commander, where you can do a lot of tweaking and a lot of changing, and I think being able to do that and have minute control over everything is a great thing. And it's great to be able to get in there and tweak something that you want to tweak and change it, and then go back to racing and go, wow, that is really cool. Plus, you can do these changes on the fly with Sim Commander. When you're in the game racing, you can have this up. If you have a 4th monitor somewhere, if you're running triples, of course, like I am, this particular screen is on my top monitor, and I can actually look up here along with some other telemetry information that I have when I'm running. And if I don't like the way a wheel is feeling, or if something else is feeling in my sim rig, I can actually play with the sliders while I'm actually on the track, which is very cool. And it will change it in real time. All right, so a lot of choices, and I guess what I really want to point out here is there's another thing called Steering Feedback Foundation, which is basically what it takes this. I guess the best way to explain it, the way it was explained to me anyway, hope this is right, is all these selections here are your basic. From the engine RPM up to game force feedback are your basic selections for the driver. And of course you can add to those base selections up here if you want something else. Now if that's not feeling right to you, or even if you want to play with it and see what the differences are, you can actually go in and click on this button and turn on your Steering Feedback Foundation. Now basically what this is doing, as I understand it, is taking over the force feedback signal that's coming from whatever sim or game that you're running, and what it does is do its own thing, basically. In other words, it does the Sim Commander way of what the force feedback is going to be. And I've tried it with the Steering Feedback Foundation. It feels okay on some cars. I really don't see an improvement for me. And again, all this stuff, before you guys get mad and start yelling at me, all this stuff is personal preference. And I drove a few different cars, and I've driven a few different tracks, and I've played with the Steering Feedback Foundation, and after all that, I just pretty much just leave it switched to off. I think that this wheel does a real good job of the feeling coming from at least iRacing and Assetto Corsa that I ran it in, and even rFactor 2, even though it's a little tricky getting them set up in rFactor 2. But the Steering Feedback Foundation, some guys will think this is the greatest thing since sliced bread, because now Sim Commander's interrupting everything and doing its own thing. But again, it's all personal preference. So if that's what you like, that's cool. If you don't like it, that's cool too. So like I said, you can really do a lot with this, and sometimes I find myself getting a little bit lost because there's so many configurations that I'm trying to change. I'm trying, even if I use a naming convention that puts everything in order, or some kind of order anyway, that I can relate to, after about 4 or 5 or 6 configuration changes, and I'm still tweaking on things and saving the configuration before, it's easy to get lost on where you were to begin with and what you were trying to change. So again, sometimes less is more, but sometimes more is more. It depends on the person using it and what your particular situation is, which car you're in, which track you're in. But the best thing about this is there's a lot you can do if you don't like what you have to try to fix it. And hats off to Sim Experience for being able to develop this very powerful piece of software here that allows us to change all the stuff we want to. But just be careful, because you can, like I said, even if you get good naming conventions, you can get lost, and it becomes a little frustrating. I mean, sometimes you just want to turn your computer on, jump in the car, and race, or drive, and practice, or whatever, and without getting in and tweaking everything for every car and every track every time you change one. But I know you guys are going to say, well, once you get to a point where you got all your configurations set and everything's great, well, then somebody is going to change. There's going to be an update to the simulator that you're driving, a new whatever the updates are that come, and then that changes everything again. Then you're back in trying to tweak your configurations again. For me, I usually just leave it alone though, and just drive with these basic settings, and I might tweak one or two based on the car track I'm running on, which is cool. I mean, like intensity or, you know, the smoothing, dampening, similar to a regular driver like a Fanatic or something like that. Anything else? Oh yeah, they have a tuning wizard here, which is mostly miss for me. Some people like it. I don't, because it just doesn't give me what I want when I use the wizard. And it's basically just running off. What you'll do is do a couple of laps, and then you'll use the telemetry. If you click on the output tuning wizard, and you can click create effect settings from recorded lap telemetry, and then next, and then you'll go pick a lap that you want, and then it'll figure it out what it should be for you. And that really did great things for me when I was using it just for my motion rig, and it's kind of the same for the wheel. I'd use it a couple of times, and I ended up just getting rid of it and sticking with pretty much what the game or the sim is sending me. But that's, again, that's a personal preference for me. But it's nice to know that if there is something in there that I need to tweak, I can. A lot of stuff in here. Now, what we're going to do now is just get to driving the wheel, because that's what it's all about. I mean, it's great having all these tweaks and what you can, you know, all these things you can change, but I found that the basic characteristics of a wheel, even with all these changes you're going to do here, are pretty much not going to change, because it's the controller board and the firmware written for the controller board that are really going to be showing the characteristic traits of how a wheel feels. That's been my experience in the past anyway. So that's really where the devil in the details is for the firmware, controller board, and that kind of thing. So we'll go ahead. Next will be an iRacing. I'm going to jump in the Corvette, go to Sebring, I think, because it's got a lot of bumps there, and just drive a few laps and see what we think. So we'll do that when we come back. Well, we're in the Sim Experience Stage 4 rig with the Accuforce wheel mounted, ready to go. And what we're going to do here is just do some laps at Sebring, which is one of my favorite tracks for this kind of thing, because it's got a lot of bumps, and it shows what the wheel is doing, and you can feel a lot what the wheel is capable of delivering as far as detail on a track like Sebring. It's probably the best track for that, at least for me. And we're going to run the C6R, like I said before, the GT1 car. And if you look up here on my fourth monitor that I run, you can see that I have the Sim Experience Control Center up here. And it has all the sliders for intensity settings, for all the feedback, smoothing, dampening, so forth and so on. I have turned the dampening down. It comes at 5%, and I usually don't like any dampening. I just like to feel as much as possible as what the road's trying to tell me and the car's trying to tell me, so I usually just turn dampening down to 0, and I've done that here. But the cool thing about this is I can change it while I'm going down the road. Of course, I'd probably slow down before I did it, because I'd probably wreck, but you can change it while you're in the game, and that goes for everything though, including the Sim Experience rig itself, the GS4 seat that I run, and the Sim Vibe that I run for actuators. So that's very cool, very powerful software. I really like it because of that. I'm not going to be running the SFF, or Steering Feedback Foundation, because it just doesn't do it for me. I know some guys love it, but I just like what I'm feeling from the normal settings up here. And, you know, not everybody's the same, so you might like it, you might not. But that's what so far, that's what I've come to the conclusion, that SFF is usually not for me. But then again, I might change my mind later on. It's always there for me to play with if I want to come back and revisit. So I will be doing some overdubbing while we're in the car running it, because it gets kind of loud here in the rig with all the actuators and everything working. So I'll just overdub there, and we'll do a few laps, see how we do, and I'll probably take my hands off the wheel here and there, just so you can see what the wheel is doing, not because I'm trying to show off. And once I'm done with a few laps, if I can do it without wrecking, then we'll get back and give me some thoughts about what it's like to run this wheel. So let's go ahead and get to that. It's time for some fun. The first thing you notice about a wheel like this is that it's very clear what the car is doing, or what your front wheels are doing, because you're directly attached to them, it seems like, for the first time when you drive a direct drive force feedback wheel. Everything is just very intense, It's very clear, and of course there's a very steady, strong feeling of the force feedback. And you can see when I let go, there's a little bit of center wobble in the wheel, which is not unusual. In fact, there are some cars that I've been in on a track that you let go of the wheel and it would do the same thing. It's like there's like this neutral area where nothing's happening right in the center of the steering. And this wheel is cranked up to 100% right now, so I've got it set to full, and it is a handful. I would think that anybody who ran this wheel, and if you got in there with 100% and tried to run it for 45 minutes, you'd be very tired afterwards. So you can see how the bumps are hitting the wheel and how sharp they are, and you can feel that in your hands. And you can see sometimes when the wheels get loose, I can correct instantly, like right there. So anytime you see a quick snap of the wheel, that means something's getting loose and you're making a correction. And you can make the corrections quicker, of course, because you're feeling them sooner. This is the big long back straight at Sebring, and you can see the wheels barely moving because it is pretty smooth out there on that part of it. But when we get into turn 13 in here, things get crazy with the amount of bumps that are in this road, or in this track. You can see the wheel just jumping from all the bumps. But you can also see how easy it was for me to correct. As soon as the bumps knock your wheels up in the air, they get loose, and you can feel that they're going in the wrong direction, and you can correct for that. It's just so much fun driving a direct drive force feedback wheel. If you haven't done it, it's really hard for me to convey that to you guys, just like back when I was doing the Bodner review. It's just hard to convey unless you have your hands on one what's really happening and how quick it happens. It happens right away, and the Accuforce is no different. You can feel when you get on the brakes, you can feel the lightness in the front end. And if I'm turning too hot into the turn, I can feel the front end washing out and can correct for it quickly. I mean, that's like right now. Just let you guys watch some of this driving here. You can see again a little twitch there in the wheel where I'm driving it pretty hard because I want it to get it to slip. I probably wouldn't drive it like this if I was in a race. I'd be pacing myself and not trying to overdrive the tires. But you can see that quick snap I did right there of the wheel because it got loose coming around that corner. But I'm trying to, like I said, push it a little bit so that I can get some slides and you can see me correcting them as soon as they start to happen, which keeps the rear end from coming around. And guess what? Just as I say that, the rear end came around. I love this stuff. All right, so back down the long straight. And you can see that it just slid right there, but I was able to catch it pretty quick. Couldn't catch the other one then. So you're not going to be able to catch everything. This wheel is not a miracle worker. And the Corvette is a tough car to drive anyway. It's one of the reasons I'm in it. It's got a lot of torque in that V8 on this C6R GT1. And you can see coming around the bumpy corner again, it's just sliding all over the place, and you can see how I corrected for it. Even got it in the grass a little bit, and you can feel when you get off the track and onto the grass. As soon as that happens, you can feel it. And yeah, the Corvette, back to that, it's a very tough car to drive because it has so much power. It just wants to come around on you all the time when you're trying to accelerate out of the turn. And it's nice to have this wheel, or a direct drive force feedback wheel, so you can be right on top of it. Even though, like I said, and you saw, you can still lose it if you push it too hard. But I find myself able to catch slides and make corrections to the front end washing out, or too much oversteer, or snap oversteer, a lot easier with this type of wheel than, say, a Fanatic or a Thrustmaster. It really is fun driving this. And I'm not using, as you noticed, the shifters because I just want to drive the stick shift, or the sequential. Just letting go there so you guys can see the bumps as the wheel translates those bumps to your hands. Try to convey again what little I can as to how that feels. You see a little correction there. In the corrections, when you're making them in the car, when you're in the car and you're driving it, because of what you can feel in this wheel, are easy to make. They're almost natural. It's like you just do them naturally. And especially, again, back on the 13 turn here, it's just, you can see me making a lot of little corrections as I go through the corner. Yeah, I'm pushing around a corner there. You can see I was pushing it pretty hard. It really gets light and likes to drift to the outside when you're coming around that corner. It's not an easy track to drive because it's pretty much flat everywhere. There's really no camber anywhere to help you out. Get a little light on the wheel there. Yeah, this is really fun stuff here. And that's what it's all about. We spend all this money and we research everything, all kinds of pieces of hardware, pedals and wheels, but this is what it's all about when it all comes together, and the wheel just works so well that it makes you believe that you're in the car. And again, that's why we do this. All right. Oh, got some big wobbles there, man. Almost lost it there. But again, this wheel just makes it just like a natural counter steer. As soon as you feel it, you're into the counter steer already. All right, we'll go ahead and go down the straight and around turn 13 one more time. See if I can make it without wrecking. And then we'll go ahead and get back in to what we think about the wheel. And then after that's done, we can do our final thoughts. Okay, that's it. You heard the voice overdub while I was actually driving, and this is a great feeling wheel. It is direct drive force feedback, so if I'm not enthusiastic enough for you about it, it's because I've actually been driving a direct drive force feedback wheel, a nice one, for quite a while now, over a year. And this, again, is a step up from Fanatic and Thrustmaster, or any belt or cog driven wheel, of course, because it's direct drive. And it does a good job. There's a plethora of, of different adjustments you can do to this wheel. I like the way it feels. Now, in the previous section of the video, you saw the flex that was in this wheel. And I can feel some of that, but I think it's because I'm used to, again, running the Momos, and there's not as much flex in the steering wheel itself. It's just this metal in here, and it just feels a little, I don't know, but you can still get the job done. It doesn't mean that you can't drive this wheel. It still gets it done. It still feels good because of the direct drive force feedback that you're getting from this wheel. Again, any direct drive force feedback, what it does is it lifts the veil. It makes things clearer to you. It makes you be able to adjust. I don't know if you saw in the video when I was driving, I was able to adjust quicker to slides because you can feel it right away when it's breaking loose, because you get that loose feeling in the front end. And of course, with your visual that you have of you getting a bad angle in the turn anyway, also helps you, but you can feel it right away. The immediacy is what the big thing about these wheels is. There's no more delay like in a belt driven or cog driven wheel. It's there now. And there's a good amount of force here. I got it at 100%. I guess it's maximum. You know, I'm not sure I'm pretty sure that if there was more force feedback intensity, that'd have it up there, but it doesn't. So I'm assuming that's the most you can get out of it, which is plenty. It'll make you tired using this wheel. It's very similar to other direct drive wheels out there, I'm sure. But again, this video is not about the other direct drive force feedback wheels. This is about the Accuforce. And Bernie and Pat and the guys over at Sim Experience can be proud of what they've done here, bringing this wheel into the market the way they have. And it has a great piece of software that runs it in real time in the game. So it's just a great package. You know, hats off to the guys for doing a great job with this thing. There are a few little things, niggly bits that I didn't care too much. Main thing is, I think the biggest thing was this wheel. But that's easily changed, and it's easy enough to put another wheel on this and change all that, which I would do if I keep this wheel. So I guess that's about it. We've seen everything we need to see as far as the review goes. What we'll do next is just go ahead and cut over to the final thoughts and talk about what I think about this wheel. Final thoughts on the Accuforce Direct Drive Pro Edition wheel system. First, I'd like to commend Bernie and his team at Sim Experience for taking a chance and bringing this wheel to market. Here we have an affordable, turnkey direct drive force feedback solution. Well, affordable relative to the direct drive force feedback solutions that have previously been available to the sim racing enthusiast. Let's talk about the cons. Well, of course, the first con is going to be price. This wheel will set you back about $1,700, including shipping, within the United States. Still, this isn't a justifiable expense for a lot of sim racers out there today, but the cost is coming down. Next is the actual steering wheel and button pod included in the Pro package. As you can see in the video, there is some flex in the wheel itself and some in the plastic housing here. Even though most folks would not feel this while driving, there are other considerations here. Once I swapped out the stock wheel and button pod with my Momo Mod 30 and electronics pod made by Sam Maxwell here, I noticed right away that this setup was stiffer and lighter. Being stiffer only enhances what feedback the Accuforce is putting out, where a wheel with flex in it can actually act to dampen the force feedback you feel in your hands. Also, the stock wheel and pod with the female quick release attached to it, which it isn't right now, weighed in at 2,200 grams, while my Momo setup here weighed in at 1,940 grams, which is right at 9 ounces lighter than this wheel, which is just over a half a pound of less rotating mass for the Accuforce to have to turn. And you can feel the difference. Now, I'm not saying that the stock wheel and pod are awful or anything like that. You can get along just fine with it. But I feel like if I don't point out these type of things to you guys, I'm just not doing you justice. Now, I originally wanted to get the do-it-yourself version of the Accuforce, but the guys at Sim Experience said that they were not going to offer that for a while. So I had no choice but to get the Pro package or lose my place in line to purchase the Accuforce. And if I had done that, who knows how long it would have been before I actually got a chance to review one. So let's get to the pros, and there are a lot. Actually, countering one of my cons, this wheel is the most affordable turnkey direct drive system available today, which is a great thing. But even greater than that is this will force others to reassess their pricing and market strategies when it comes to direct drive force feedback systems, which can continue to drive down the cost of direct drive force feedback wheel systems, which is exactly what I like to see, like most of you. Next pro, well, it's obvious. This is a direct drive force feedback system. It outperforms any belt-driven, cog-driven, screw-driven force feedback system out there. Direct drive eliminates most, if not all, of the force feedback transmission loss, and maybe even more important, the delay inherent in those systems. When you drive a direct drive force feedback wheel, it truly is a revelation when coming from any other type of force feedback drive. It is as if a veil has been lifted from what we're used to feeling in other systems. It's just all-around force feedback driving sweetness. Next pro is a Sim Commander 4 software package that you use with this wheel. It is a marvel at what this software is capable of. I've been using it for some time now, driving my Stage 4 rig, GS4 motion seat, and SimVibe with it. And although I may not agree with what it thinks is best, at least I have the options to change it, and a lot of options there are. And the Accuforce force feedback wheel is no different. You can change the settings and tweak on this wheel till the cows come home and still not get to the bottom of what this program is capable of. But I also have to say, sometimes too many choices can make it hard to make a choice. And there may be a bit of a learning curve here for the uninitiated that's never used the software before. There is a wizard feature available that lets you run some laps, then let the wizard determine what settings should work for you the best. I never really got what I wanted when I ran the wizard, but I do see where it could be helpful in finding a basic setup if you need to get started with one. But at the end of the day, the software can be as simple or as complex as you personally want it to be. And I've been around the folks driving force feedback wheels long enough to know there's no people who like exactly the same thing when it comes to the feeling out of these. Overall, I can recommend the Accuforce drive system to anybody who can afford it. Direct drive force feedback is really that good. You won't be disappointed coming from any other type of force feedback driven systems. Now, on a side note, I know there's a lot of folks who want to know if the Accuforce system is as good as or better than the Bodner system. But that's not what this review is about. We are currently working on a direct drive force feedback comparison video. And this is where you will see the Bodner, the Accuforce, and an example of the do-it-yourself or OSW wheel, I think it's called, compared head to head. Then you should be able to reach your own conclusion as to which one will be the best for you personally. I'm Barry Rowland, and thanks again for watching the Sim Racing Garage channel. Cut. And cut!